We're going to use a mixture of your textbook, Desmos, and our teacher notes today to work through section 7.8. If you have any questions or anything, please let me know. I'm going to try to keep the coloring kind of similar to what I did on the teacher notes. I picked red for anything dealing with amplitude, pretty blue for anything dealing with period, and then as we get to other stuff, I'll let you know these colors as well. So if we recall from last chapter, how did we find amplitude? Where is it at, and what's the process to find it? Do you remember? So we find it by taking the absolute value of it. So that's first off. And it's typically found in front of the function. So it's the first thing you see, whether it's positive or negative, it's going to be there. So in our case, it is 5. Okay. And period is found by taking omega, which that's what a lot of students like to call the double W's or W, but it's actually a Greek letter called omega. And in our case, it is going to be what? What is your omega? It sits in front of the x.
Yeah, it'd just be 2, wouldn't it?
Yep, it is 2. And what we do with omega is to find period, which period is a capital T, we take 2 pi divided by the omega, which my omegas are always going to look like, they're going to look weird, always. So 2 pi divided by 2 is just going to leave us with a period of pi. Okay. Now, on my teacher notes, you will see a not perfectly drawn function, but I would like you guys to see it a little bit better. So we are going to go over to Desmos. And I will show you, I'm actually going to do a new Desmos because that is for later. Okay, are you guys seeing a blank Desmos screen or no? Yeah. So I'm gonna type in 5 sine of 2x minus pi. Now you guys can also use Desmos. It's really up to what you feel most comfortable with. Honestly, with being online, I think Desmos is pretty nice and pretty powerful. It obviously doesn't do everything, but if you work in combination with Desmos and a regular graphic calculator, you really should be pretty good. The points that you would have wanted to sketch, I started at the top because it gave it to you. And then I went to, I believe, 9 pi over 4. Oops. Nope. Okay. So I would take your time and draw that out in the section that it gives you. And then just let me know when you're ready to go back into the notes. Okay, so when you were taking a look at that graph over on Desmos, does the sketch have the amplitude and period you were expecting? Does it kind of match up? You feel like it matches up? What do you think? Yes, no, maybe? If you compare it to the regular sine function, you know, sine bounces between 1 and -1. And we had an amplitude of 5, so we bounced between what? So just so you can all see it written down, we had an amplitude of 5, and then we had a period of pi. And that was pretty evident on the Desmos, right? That matched up. So we're going to go with a yes. Okay. Does the graph look like a typical sine function that we saw from the previous sections where one cycle goes from 0 to 2 pi? What do you think? What do you notice about that cycle? The cycle relates to what? What does your cycle relate to?
To the period.
Mm-hmm. So this one would be a no. Why? Because we have a period of pi, not 2 pi. Okay. So we had a shift, a horizontal shift of pi units. Okay, go ahead and make sure you write all that down. Okay. This value represents what is called a phase shift. Okay. To see the connection between the phase shift and phi, complete the following. So phi, I used red on the front of that sheet, but that's not what I used all the time. So I used orange for phase shift. And I'm very sorry that my phis on the computer are pretty bad. Draw that, and then we'll try to draw. Nope. There we go, close enough. All right. This section isn't actually too bad, so please let me know if you have any questions on it. Are we all good with that? Okay, good. The next little section just kind of has us restating what we already know. Amplitude is the absolute value of A. Actually, you know what? I can put, yeah. Okay. Period. Period is a T. And then it's equal to 2 pi 2 pi divided by omega. And then phase shift is phi divided by omega. Okay. And you can kind of see they gave you a pretty nice diagram there that you can go ahead and draw. You're definitely going to want to have that to reference back to. This basically breaks down, if you remember at the end of Monday's class, we talked about the 4 steps to drawing sinusoidal curves. So and I do have to apologize for the next example coming up. My printout had the graph on the next page, so I ended up drawing in my own graph. All right, so let's clear this out and work on the next example together. So I want someone to tell me what's going on. You guys give me the answers. So the graph we're focusing on is y equals 2 sine of 2x plus pi. So before we do any kind of drawing, we want to figure out some things. The first thing we want to figure out is our amplitude. So what is our amplitude?
Wouldn't it be 2?
And what I'm going to do is I am going to put it into the absolute value because I want you guys to get into the habit of doing that, because your amplitude, when you're asked just for the amplitude, is always going to be a positive. Someone walk me through the period. How do I find the period?
You would find the period by dividing 2 pi by, what's it called, theta, which is also 2. So that would be just pi, because the 2's cancel out.
Very good. Okay. And someone else walk me through our phase shift.
Is it 0?
It's not quite 0. So look at the difference between what we're given as our form and what we're given as the function they want us to talk about.
Oh, is it pi?
It is, but it's actually a negative pi, because if you see here, we have a positive.
Yeah.
Then in the form, it should be a negative. So we're going to go with a negative pi
Okay.
over 2. And I guess I should let you guys know that is a fraction bar. Okay. So what you can also realize, though, from a phase shift is if we want to say that the cycle begins at 0, which that's where we typically like to start, but you know what? We can also start at our negative pi over 2. That's okay to do. So negative pi over 2. And then it's just going to end where? Where would it, how far would it go, basically?
It would end at a 0, 0, 0.
Okay, so, oops, sorry. So there is a little bit of a side note here, which I did not, I apologize, I did not put it on my teacher note. So you definitely want to take note of it. I might end up retaking a picture of my teacher note. So to find the end point, so we begin the cycle here at x equals negative pi over 2, which we just found. To find where it ends, we're going to take, there's another small formula, so I want you guys to write all this down. X is going to equal what we just found for our phase shift. So that same formula, so phi over omega plus 2 pi over omega. So what would that end up being here? So what we know, our phase shift is negative pi over 2. So we're looking at where your starting point is, negative pi over 2. And then we're going to add pi. So where would our ending point be?
Pi half.
Oh, that's a terrible pie. Doesn't look pretty at all. Okay. Okay. So wow, I gotta redo that whole page. That stinks, but all right. Sorry, I apologize. All right, so the next part that we're gonna work with, I wish there was a brown. There is a brown. So I do my sub-intervals in brown. I don't know if I told you guys this or if I told my algebra class this, but I have got to use like color coding for this, or I've like lose my mind. So the next thing we're going to do is our sub-intervals. So what we're going to do is we're going to take each length, which is just pi, right? Our period is pi. And we're going to divide it by 4. Okay? So you're going to have 4 sub-intervals. The first one, like if you were to do it on a number line, the first one is pi over 2. You leave that out front. The next spot, you would do pi over 2. And then if you added pi over 4, what would you get as your second bound there? What would you guys get? So essentially, what's pi over 2 plus pi over 4. What's that going to get you?
3 pi fourths.
Mhm. Okay. Are you guys okay if I erase some of this so we have enough room? Yeah? Okay. I really hope some of you guys are paying attention because let me tell you, this stuff is not the most easy to figure out. Okay, so what we do for the next subinterval, we're going to start where the last one stopped. So we're going to start at 3 pi over 4. And then we add another pi over 4. So that takes us to just pi, right? And these have to be brackets. Can anyone tell me why they're brackets?
Isn't it because they're included?
They're included and they're not points. And when we get to the next line, we're going to be dealing with points. And I think they do it so you guys don't get confused, or so no one gets confused. Okay, so pi is basically equal to 4 over 4. So then if we add another fourth, we're looking at 5 pi over 4. And then I'm going to show you a trick when we go back into Desmos. If you have a hard time figuring out your key points before you graph them, you can always use Desmos first, graph it, and then it kind of shows you your key points. Okay, so before we plug all this in, I like to go to Desmos. And that was the old one. So now we're going to type in the new one. 2 sine 2x plus pi. Okay. So if you go to where we're supposed to start at, pi over 2. And negative pi over 2. This kind of goes through and it shows you basically the 5-point summary. Now, when you look at your key 5 points, which obviously you can see right there, I have more than 5. 1, 1, 2, 3, 4, 5. Okay, so if we take some of these away, if you look at just the ones that we're focusing on here, is that really enough to get you an idea? I guess so. That's basically one whole thing. What they kind of tell you is if you draw out a function and it just doesn't look complete enough to you, you're allowed to keep going. But typically when you do the 5 points, you almost always look like you're good to go. Okay. Do you guys have any questions on finding the amplitude, finding the period, finding the phase shift, finding where the cycle begins, doing your subintervals? finding your 5 points, and then graphing. Again, you can use Desmos to graph. Okay. All right. If we look at this graph, and then we want to add 2 to the outside of it, what happens? So here's the initial graph. Let's type it out again. But this time, we're going to add a 2 to the outside.
Yeah, it's gonna move it up.
Okay.
Y-axis.
It moves the entire graph up. So this is where we start to see an actual vertical shift. And that's where beta comes into play. Okay. So I'm going to take you to your textbook real quick because it has a really good set of steps for you. Okay, here you go. I highly suggest you all write down the summary steps. And all this is going to be on, obviously up on the YouTube video. So if you need to, you can go back through and you can pause things and rewatch. So we're going to take a look at your notes again. And this time we are going down to the last example. I want you guys to write out your points. You don't have to worry about writing out the month, comma, the points, but you should do 1 through 12. And then here's the average temperature for the month. Should I zoom in? I'll zoom in a little bit. So go ahead and write all of this down. So again, month 1 through 12, and you can just title it month, but then just number 1 through 12, and then do average monthly temperature, and go ahead and write your temperatures down. Because we're gonna work through this problem, and it was so cool. I thought it was cool. So I'm gonna walk you through how I did this, but before, yeah, I guess I'll show you that real quick. I put this into Desmos, and let me show you what it looks like when you're ready. Okay, does everyone who chose to write down the problem have it down? Okay, so this was really cool. I went over into Desmos and I typed in the points. So that kind of shows you where they are. I'm not going to show you the table just yet because it kind of shows you something else at the same time, and I want you guys to see that separately. So we're going to come back into the notes. And somebody walk me through, we're gonna find our amplitude, but to find your amplitude when you're given a scatter plot or a model like this, it's a little bit different. Your amplitude ends up being pretty much like your range. So if we take our largest data value and subtract it from the smallest data value, what do you end up getting? What's your largest data value?
Largest is 56.
Mm-hmm. And then our smallest is in January, and it is 24.2. Right? When you work that out, what do you get?
Yeah, like 31.8.
And then go ahead and divide it by 2.
Wait, that was the total. Sorry.
That was your total?
Yeah.
I might want to try that one again. So
I got 15.9.
there you go. Yeah, 15.9. You might have just forgotten a period or something somewhere. It's all right.
To divide, that's why.
Yeah. Okay. So that is how we find our period when we're dealing with a model. The next thing we're going to find is our vertical shift. And I'm going to have to delete what I've done because when we go to move, it will go away. So, all right. So the next thing we're going to do is our vertical shift. And I believe that was, what color did I make that? Brown. Gross brown. Okay. Don't know why, but that's what I picked. All right. So, the largest value again was 56, and then we had our smallest value, which was 24.2. Then you divide that summation by 2. So what do you get there? I'll let you guys work on it for a second.
$40.1.
Excellent. Okay. So the next thing we're going to look at is the period. What do you know about the period for a year? What do you think the period is for a year? If you guys were to take a guess.
365 days.
Close. I mean, that's equivalent. They're going to go with 12 months. But 365 makes sense because if we were dealing with days, that would definitely be it. So if we solve to find our omega, we're essentially going to be taking and swapping the 12 with the omega, right? So 2 pi divided by 12 is going to give us omega, which is just pi over 6. Okay. Now this part kind of comes from looking at the year, but if we look at the regular sine of x, we have a max at x equals 3. Then in our scatter diagram, the highest value occurred in July, or x equals 7, which means there was a horizontal shift of what? And what's that difference there?
4.
Mhm. Okay, so if we were to try to write this whole thing out, y equals our amplitude. I'll give you guys that one because we had to erase it to make room. Our amplitude was 15.9. Okay. Sine Okay, our omega is pi over 6. And then it's x minus 4. And then you had a vertical phase shift of 40.1. Now you can go through and you can rewrite it, distributing the pi over 6 if you like. I would accept either answer on an exam. I cannot tell you what Pearson will accept. I assume they would take either. Even if you do and they don't, just email me and I will go in and override it because I feel like equivalency is normal. Okay. Okay. So this is super, super cool. We are going to go back into Desmos and we're going to type in the function we just found. Okay, so we're going to go back into Desmos. Now, right now, what I did is I took the function off. But when I pull this back out, you can see my table here. You can see the function that I wrote out. And then if we want to check it, we just click it on. And do you see how nicely it lines up? Now, let me just tell you that in our textbook compared to the teacher notes, they love to do the opposite to me. So in the textbook, our example was a sine. So when I was going through and trying to figure this out for my teacher notes, I was like, well, obviously they keep giving me the opposite. So I'm going to go with cosine. And that's what it looks like. So then I sat there and I kept playing with it and playing with it and playing with it. And no matter what I did, it did not line up. So then when I finally got frustrated enough, I went with the same thing as the textbook. And of course it worked. But I just wanted to show you guys that because I think it's super, super cool.